now we'll continue solving tutorial 2, soil. That's question 2 now. Okay. First, I apologize for the dirty board, but no choice. So that's what's given in the question. We have a solid element that's been rotated 20 degrees. We've got both axial stresses, sigma z and sigma x applied with a shear. Sigma x and tau are given. However, the question asks what would be sigma z if the measured principal stress equal to 100 kPa. Okay? So there's two ways to solve this part of the question. Using the equation way, you can say that sigma 1 equal sigma x plus sigma z over 2 plus the radius of the circle. Okay. So you can see sigma 1 is given, x is given, and tau is given. The only thing missing is sigma z. So you can say that sigma 1 equals 100, sigma x is 30 over 2, that's 15, plus sigma z over 2. Sigma z over 2 minus 30 squared plus tau xy, which is 20 squared. Okay, we can move this to the other side. Now we have 100 minus 15 is 85, minus sigma z over 2 equal to square root of sigma z over 2. Okay. Now to get rid of the square root, we can square both sides. Square both sides. Yeah, so there was a small mistake. This is 15, 30 on 2, right? Sorry about that. Okay. Now if you take both sides squared, so we have 85 minus sigma z 2 squared equal to sigma z minus squared plus 2 squared. Okay, now you can expand on this. Do that. So what we have is 85 squared plus sigma z squared plus minus 85 times sigma z over 2 times 2, that would be 85 sigma z, right, because a minus b squared that's equal to sigma z squared over 4 plus 15 squared minus 15 sigma z plus 20 squared. Okay? Now sigma z squared over 4 and sigma z squared over 4 can be simplified. And so what we'd end up with after simplification, that's 70 sigma z equal to 6,600, and therefore sigma z equal 93.4 kPa. Okay, so that's the end of it. It's quite simple to understand. It's just one equation, but to simplify the equation is a very tedious amount of work. That's simple. Okay, so the other way is using more simple. Here at this point, we have sigma x, which is 30, and tau, which is 20. And on the side, that's the center of the circle. We have sigma z and minus tau. You might be asking, how do I know this is minus tau and this is plus tau here, although there is no sign given on the diagram? Well, the sign convention is as following. If the shear on the vertical side is going anti-clockwise, that would be positive. If it's going clockwise, that would be negative. So you can see here the shear is going anti-clockwise, so that has to be the positive shear and that's the negative shear. Okay? We're trying to find sigma z. So if you look at the Mohr circle, it's given to us as 100, right? Okay, so this distance, let's call it x, will be the same distance as this it's also the x. Correct? Because they pass through the center of the circle. So basically, if I can say that sigma z is sigma x, this is sigma x, sigma z equal to sigma x plus 2 x's, right? Make this rule. So if I can find x, I can find sigma z, right? Okay. So from this triangle, I have the height is 20, right? Because the shear is 20. And if I can find that this is what this angle is, I can find this x. So that's my idea. What's this angle? Then I remember I have this was 100, so I want to try to use this information. So I go, okay, this is 100, this whole distance from the center to sigma 1 is 100, from the center to sigma x is 30, then this must be 70, right? 70, 100 minus 30, 70. Then I go, okay, so I have 70 and I have 30, I can connect to a triangle, which looks something like this. I have 70 and I have 30, okay. Then I go, oh yeah, it's good. So if I can find this angle, which is this angle, both these angles, they inscribe into this arc, okay. That means this one, this angle, if this is alpha, this is 2 alpha, okay, because they inscribe into the arc. So this alpha one, I can find, I can say alpha, 10 alpha equal 30 over 70. Therefore alpha equal inverse tan 30 over 70. Sorry, I'm saying 20. Take that back. 20. Okay. Therefore alpha equal to 16 degrees. Roughly, it's actually 15 for now. Okay, so 2 alpha is 32. That means I have 32 here, and I have this is 20. So what is x? Okay, so then I can say that 20 over x equal 10, 32. Therefore x equal 20 over 10, 32, which is 32.47, right? Then I can say sigma z equal to sigma x, which is 30, plus 2 times 32, 14, which is 94.3, 93.4. Okay? So this is a bit more difficult to think of solution. I don't recommend you to attempt such things in the exam, okay? Because it could take some time to actually visualize and get an answer. While the equation is straightforward, okay? So that's the solution for part A, and let's see part B. Yeah, I'll keep the circle. Part B asks, what is the angle of the major principal stress plane? Okay, so you can imagine that if I can raise these. That this element will have to rotate some angle, okay, theta, has to rotate angle theta from its current state to the new state, where we have only principal stresses. multiply 2. Okay. So what's asking what this plane is, angle. So what's this angle with the horizontal, which is this whole thing, which would be theta plus 20, right? Let's call this theta. Okay. Right. So if you can find theta, you can have it. Okay. Yeah. So I want to find theta. So a simple formula would be that tan theta. Check the formula. I think it's that 2 theta. Tan 2 theta equal to 2 tau xy over sigma z minus sigma x, right? That's in your handouts. So tau xy is 20 over sigma z, we've already done. 93.4 minus 30, and therefore theta would be, I think, again 16 degrees. Okay. So therefore theta is 20. So that would be 16 plus 20 ends up to be theta 236 degrees. Yeah? That's the answer. That's simple, right? Let's try to attempt this using Mohr circle. I hear where stuff gonna get really, really messy. Okay? So if you do this in the exam, you get 2 marks. Done. Nothing more. Just want to show you how to do the Mohr circle so you can find the use of this. So, pause it. Okay. So I just did the circle now. So what happened? I've connected this stress and this stress 9 degrees, and they both met at the OP. Okay. So OP is the original point, which is this point, where both stress planes meet, okay? And it's exactly the same point to which the plane, the stress element would rotate. So the element would rotate about OP. What that means? That means also I can connect sigma 3 and sigma 1, okay, through OP, again using 90 degree. So all stresses meet at one point, OP. So the previous stress, which is sigma x and sigma z, okay, they had this angle with the horizontal, 20, same as this, okay, 20. And then the element was rotated to the green line, okay, and the difference in angle is theta, correct? Then we said the whole angle, which is theta plus 20, is beta, right? Now we want to try to find theta. Okay, here's the mission. How do you find theta? So we can say if this is 20, then okay, this is a very crooked line, right? It's a straight line. Redraw it. Pause. Okay. So if this is 20, that means it's 20 from looks like that, this shape. It's gonna get very messy, guys. Okay. That's 20, it's 20, and this 20 is describing into this arc. Okay? Now if I connect a line here, at sigma 1, okay, we could say that because this angle here, okay, is also describing to the same arc, that also will be 20. Okay, if you noticed, this angle here is described to the same arc. So that using arc and angle rules, that would be the same angle, right? That means this is theta, the angle that we're looking for. Yeah? Now, so this angle is the same as this angle. Why? Because both of them connect to, this is minus 20, this is minus 20, and this is 20. It's minus 20 because it starts from sigma z, and this starts from sigma x. That means these two are the same, and it's the same shared line, so theta must be alpha. Alpha is 16, but So beta again is beta plus 5b is 36. That's another way. Obviously, like I solved it now because I already know the solution. But in the exam, it would take much longer to actually figure out angles and arcs to solve this question. So I really recommend not touch it in the exam, okay? Just solve it using calculator. And that's the solution to our question 2. Thank you.